Swayam Prabha. Digital India. Educated India.
Welcome back. This is the 14th lecture for the project management. 14th means you have already completed 2 weeks, 5 lectures in each week, and this is the last but one lecture for the 3rd week, which is the 14th one. So, as we were discussing, I just in the last lecture, which is the 13th one, I just ended with a 1 or 2 minute introduction about utility analysis and how it will have a sense about decision tree we will try to understand. So, let us start with the full vigor and full force about utility analysis. Consider the same type of construction project is being undertaken. Now, we are coming into the realm of again project management, even though I am trying to give you different examples, but those concepts can be utilized in project management and other fields also. So, now by more than one company who will consider who are considered in these projects and investors. Now, different investors considering the investing that money, time, energy, skill, everything have different attributes and risk perspectives for the same project. So, that is to say the project each investor has with him and her an opportunity set such that based on the opportunity set the particular group of persons or the individual persons or the investor who is trying to build up that project will make a decision. So, again considering continuing the discussion, consider a shop floor manager has 2 different machines marked A and B, both doing the same type of operations. Consider is a grinding machine, both of them do the grinding work, or considering is a lathe machine, they do the lathe work. Considering they are say for example, the CNC machine, they do different type of jobs. The outcomes from the 2 different machines are given. How? Let us see this table. So, in the investment process, even though the heading means investment process, I am considering the investment from the point of view of an investor or a project manager. So, now the machines are A, B, and if you see the first column, which are the outcomes, the second column is PI is the corresponding probability, then you have the outcomes for in the third column. So, I am just using the word outcome. Outcome basically means on the value sense, not rupees, not dollars, not yens, it means something else. I will come to that. And the last column is related to again probability. So, the first 2 columns are specific to the machine A, and the third and the fourth column are specific to machine B. In reality, what would the person do if he or she has 2 outcome sets in front of him or her? So, if I consider the outcome values as given 15, 10 and 15 for machine A and 20, 12 and 8 for machine B, it technically means the values of the output, the so called utility of the output for machine A is 15 with a probability of 1 by 3. Similarly, for machine A, for the second value, whatever the value is, now the value is I am seeing what is coming out, I am not seeing what is going in. Like to give you a very simple example, even though that would make sense later on if we continue the discussion of utility. Consider there are 2 human beings, one is a rich one and another is a poor person. So, the net worth of a 100 rupee note to person 1 who is rich and the net value of the 100 rupee note to a person who is poor has 2 different implications. So, the 100 rupees may only buy, say for example, for the first person he or she would only buy a chocolate, a set of cold drinks, which is worthwhile to him or her. But while for the second person who is poor, he would basically try to spend it on trying to buy some rice, some pulses, some vegetables and milk or ghee, whatever it is. So, that net worth of using 100 rupees would be different for these 2 different persons. So, the values which are there 15, 10, 15, 20, 12, 8 are those values, what is the net worth, not the 100 rupees what we are trying to utilize. So, the corresponding probabilities are given that for 15 1/3, 10 1/3, 15 1/3. Similarly, for the second machine or second decision, it is 20 1/3, 12 1/3, 8 1/3. Now, the question may arise that why did not I combine 15 1/3 and 15 1/3. What you are seeing in front of you 15 15 are the net output, but the equation based on which we are trying to find out may be such that the overall amount of input on a monetary sense for these two 15 may be different, even if the f of x value what you are trying to get for these two equations which are there in front of you are the same. So, in reality what would the person do if he or she has two outcome sets in front of him or her? So, for A, the net value would be found out multiplying by 15 into 1/3 plus 10 into 1/3 plus 15 into 1/3. So, you take 1/3 outside is a common, it will be 15 plus 15 30, 30 divided by plus 10 which is 40, 40 divided by 3 would give you the value of 13.33. Similarly, if you do it for B, again it is 20 plus 12 plus 8 which is again 40 divided by 3, because 1 by 3 is constant, hence the values are 13.33 for both the cases, which means that if you are trying to find out from the point of view of the so called picture which is given in front of you, you as a person would be so called indifferent between decision A and decision B or project A and project B. Now, let us pause here for 1 minute. The outcome values which are given in the first column and which are given in the third column may be specific to a person. Say for example, if I am trying to analyze the same problem from person 2 for the same type of inputs, like consider this, the inputs for 15, 10, 15 for the project A and 20, 12, 8 for project B. Say for example, it is, let me give you some values in the algebraic sense, note certain values, not 10, 20, 30, 40. So, not for that, but just to make you understand. If you input x1, you get 15 rupees. If you put x1, you get 20 for A and B. If you put x2, you get 10. If you put x2, you get 12. If you put x3, you get 15. If you put x3, you get 8. Now, these 15, 10, 15, 20, 12, 8 are for the first person. If a second person comes, if I try to analyze the problem in the same way where it is x1, x2, x3 for project A and project B, the outcomes need not be 15, 10, 15, 20, 12, 8, because that person will try to analyze this problem from his perspective, for which the function and value or so called utility functions, I am mentioning the word utility functions for the first time, may be different. So, in that perspective the problem would be framed accordingly. Now, let us change the probabilities. So, the probabilities are now 15, 10 for 15, 10, 15 it is now 50%, 25%, 25%, and the outcome for the concept related to the decision B remains the same. So, in this case A would have an expected value of 13.75 and B would have an expected value of 13.33. So, I as a person who has in front of him this set of values where the probability has changed, now it is 13.75 A. So, hence I will take decision A. Let us extend this problem to a second type of analysis, very simple analysis, where there is a match, football match or cricket match, whatever you think you are interested in. So, the outcomes are given as win, draws, loss, and I am trying to analyze the position of two different teams. Let us name them as X and Y. So, now due to some reason, one of the organizers of the match or this tournament had mentioned that the outcomes will be point accordingly, where a win will fetch 2, a draw a 1 and a loss 0, while other organization due to some confusion said the win would fetch 1, a draw would fetch win would fetch 5, sorry, my mistake. A draw would fetch 1 and a loss would basically fetch 0. So, in that case the points earned are different and the wins and draws are different. So, if I try to basically bring that in the picture for case 1 and case 2 and try to compare team X and team Y based on case 1 and case 2, the situation is like this. In case 1, team A has 100. So, how do I get 100? I multiply the probabilities and the points. B has 95, which means that A has a ranking higher than B and A would win. Suddenly the organizer 2 comes huffing and puffing and he or she says, no, the point system is different based on case 2. If I do the point system as given, then in that case team A has 220 and team B has 230, hence again the trophy would now be given to the other team, which is B, which is definitely not expected, but that is the confusion which may create if we have different type of point system for the same type of concept which we are trying to analyze. So, on a general framework, we have been mentioning that try to find out the summation of the probabilities, multiplied the values and such equations. So, generally the concept of utility and the value of expected value of a utility is given by this. So, if you see UW is first, let me clarify it, it means the utility for the net investment W. W is in rupees or dollars. So, that would always be positive. U suffix W is the utility, which is the net out effect which is happening by investing W. And the second term, which is a ratio with NW in the numerator and summation of NW in the denominator, it basically means the probability. So, the probabilities which you saw 1/3, 1/3, 1/3, or in the other problem for the machine, it was half, 1/4, 1/4, and so on for these other examples. That means in the denominator you have the total number of outcomes, and in the numerator you have that particular outcome for which the utility is given as UWs. So, as W changes, UW changes, as W changes you will have different number of outcomes, corresponding to that you will find out different probabilities. So, technically the equation which you have on and with its right hand side, the term which is the last, which is NW divided by summation of NW, is basically the probability distribution corresponding to the occurrences of any particular decision for different outputs. Output means different outcomes which are happening. Here UW is the utility, which is a function of the wealth, while NW is the number of outcomes with respect to a certain level of income. Remember, in general utility functions cannot be negative, but in many functions may take negative values. We will try to skip that and put 0 for negative values. Now, if you remember, let me pause here 1 minute, go back to the drilling problem. In one of the drilling problems, the value was coming out to be negative, if you remember that. So, in that case we could also have taken a value of 0 and proceeded with our calculations. But the lucky part was that if there is no drill, that one arm was 0, and in this case where it was a negative part, it was also 0. So, in any case it is 0 in both the cases, whether you take the negative sense or the 0 value for the net outcome. For analysis, we will make the problem simple. We will consider the value to be 0, even though in actuality it is negative. Let us consider so called a third explanation or different time to explain the concept. Consider an example where a single individual is facing the same set of outcomes at any instant of time, but we try to analyze his or her expected value based on the utility function. But let us, for the time being, and this is the first time we are trying to do that for explanation, we will consider different examples later on where the utility functions are different. In bullet point 1, the utility function is simply a linear equation W, and this bracket 1 means the for the equation plus 1, and the second bullet point is a quadratic one, that is W2 square, 2 in the bracket square plus W2. So, you have the outcomes again Now, outcomes are so called the numbers based on this, not the outcome values, they are the outcome numbers. So, they are given in the first column. Then in the second and the third and the fourth, it is corresponding to utility 1, the values on investment W, that means 1 rupee, 2 rupee, 3 rupee, and so on and so forth, while UW1 is given in the third column corresponding to the W values, how you find out the utility, and the fourth column PW or the probability is corresponding to the outcomes which you have. So, if you find out the total sum here, in this case, this one I will just highlight in the sense just mark it. So, this is 100. So, if you divide by 15 by 100, it becomes 0.15, 20 divided by 100 becomes 0.2. Similarly, for the last one, 25 divided by 100 becomes 0.25. Now, if I go to the W and the UW value, 1.5 when I use the first equation, which is 1.5 plus 1, which is 2.5. Similarly, if I go to 2.5, 2.5 plus 1 is 3.5. So, these utility values are given for the W's. Similarly, if I go to W2, which is the fourth, the fifth and the sixth column, these values are given for the investment. These are same, just for simplicity. These UWs are the values found out using utility function 2. So, for the first case it will be what? 1.5 square plus W2, that is 2.25 plus 1.5, you will basically have 3.75. Similarly, if I find out for 2, 2 square is 4, 4 plus 2 is 6. So, I find out all the values, the corresponding probabilities remain the same. Accordingly, we find out the expected value. How do we find out the expected value? It will be this into this plus this into this till the last term, this into this, sum them up. Similarly, for utility 2, that is 3.75 into 0.15, continue doing this till the last term, which is 30 into 0.25, add them up. I have the expected value is 3.82, second one is 12.69. So, we have a different decision based on the fact that somebody is using utility function 1 or utility function 2. Continuing with a different ideas for the utility functions. Again, two different utility functions. First is again linear, W1 minus 5. Second one is basically a nonlinear function, not quadratic. The outcomes are given, the wealth W is given and utility is given. So, now and the utility for the first one and second one is given. This is the third and the fourth column. Now, what is interesting to note is that the last two columns basically mentions decision A and decision B, which means that whether the outcomes are specific to decision A or specific to decision B, it can be possible that for one of the projects, that if I am trying to basically build up a project in the state of Assam, I may get some tax benefit. So, that would basically be coming into the picture. So, how I do that from the outcome perspective, I will consider that. So, for the decisions A, the first one is A, next two is no, then the next two after the no's is again two yeses and then a no. For decision B is no, yes, yes, no, no, yes. If I try to find out the utility concept using A for utility function 1, sorry, let me put it not A, 1, for decision A and B, it becomes like this. Now, if you see it, if utility function is basically 0, why? Because if I put 4 minus 5 is minus 1, we will consider its negative being 0. So, we will put it 0. If it is 5 minus 5 is 0, it is 0. So, based on that we find out this calculation. Now, if I do it for utility 2, it is basically 2 into 4 minus 4 to the power 1.25, I find out these values. Now, for decision A's, yes and no's are given, yes and no's are given. How do I utilize? Consider the first term. This is the utility value which is coming from here 0, and why this term 8 divided by 8 plus 6 plus 9? Because out of the outcomes, if you see yes, this is yes, this is yes and this is yes. That means 8 divided by the total numbers, which is 8 plus 6 plus 9. Similarly, for the second one, which is yes, is 2 utility multiplied by 6 divided by 8 plus 6 plus 9. For the last one, which is yes, is 3, and what is the corresponding probability of that is 9 divided by 8 plus 6 plus 9. It comes to 1.69. Similarly, if I do for B, which is for this function, for this decision, sorry, for the utility 1, so it will be yes here, so 0 into 3, 0 into 3 and divided by what? So, what are the yeses? 1, 2, 3, which is 3, 4 and 5. So, here you see 3, 4, 5. If I continue doing it, it will be 1 into 4, that means yes, 1 into 4 divided by 3 plus 4 plus 5, and the last one is 4 into 5 divided by 3 plus 4 plus 5. I have 1.692 for utility 2. Again I do the same calculations, I find out 2.5, 2.5. So, what is interesting to note is that again type of problem which we did for the football game or the cricket game match. So, if I try to use utility function 1, then I would definitely rate decision B to be better than decision A. But in case if I am trying to utilize utility function 2, then you will see that both the values are 2.5. That means I am indifferent based on the utility I am using. So, I would basically take either A or B. So, consider a very simple example. A venture capitalist is considering two possibilities of investment. Consider they are projects. The first alternative is buying government treasury bills, which cost, buying is also a project. If I mention the project is in a very big sense an example. So, which costs 6 lakhs, while the second alternative has 3 possible outcomes, which are costing 10 lakhs, 5 lakhs, 1 lakhs with corresponding probability of 20%, 40%, 40%. Consider the utility is quadratic. So, in the first example, alternative has a utility value of 776. So, why it is 776? Government treasury bills do not have any risk, which means probability is 1. So, if I want to find out the expected value, it will be square root of 6 lakhs multiplied by 1, which will give me a value of 776. So, if you can find it out through calculations. Again I am mentioning the first decision would have the expected value as square root of 6 lakhs. Why square root? Because the utility function is w to the power half, and y multiplied by 1 because it is a treasury bill which is a probability of 1. If I come to the second decision, what are the outcomes? There are 3 outcomes, 20%, 40%, 40%. What are the values? Values are in monetary sense are 10 lakhs, 5 lakhs, 1 lakhs. What are the corresponding utility? It is square root of 10 lakh in the first case, square root of 5 lakh in the second case, and square root of 1 lakh in the third case. So, the expected value would be square root of 10 lakh multiplied by 0.2, square root of 5 lakh multiplied by 0.4, square root of 1 lakh multiplied by 0.4. So, do the calculations yourself and find out the value comes out to be 609. So, hence the first alternative is chosen. Now, let us mention few things. If you change the utility, make it say for example w to the power 1/4 or w square or w cube or w to the power 2/3, whatever it is, you will find out the corresponding utility functions are changing. Hence, the expected value of the utility would also change. Say for example, it is w square. So, in that case w square it will be square of this value multiplied by 1 for the first decision. For the second decision, it will be sum of 3 terms. What are the terms? The first value of w square multiplied by 20% or 0.2, 5 lakh which is the w value for the second outcome in that decision square into 40%, and the third one is 1 lakh square into 40%. So, you can find it accordingly and compare them. So, for the above problem, the question definitely comes is that if we had used a utility function which is of the value of w to the power half plus a constant c value, would it change the overall outcome? Answer is no, because w is there which is fixed. Fixed means in the sense the functional form is fixed, then we will have basically the value of c being coming into the picture, which would have basically no effect in the calculations accordingly. So, now consider a security investment. the price of the security fluctuates in such a way that it is given by log of the prices. So, log of the prices gives you the total utility. Number of days is given on a simulation sense. Prices have been, say for example 1000 for how many number of outcomes, for out of those 100 days is 35. Price is 19 to 25 of how many days is 5 days, and the corresponding utility is based on the fact that you find out log of 1000 6.91, log of 950 is 6.89, 6.86 and so on and so forth, on which are the prices given on the second column and the utility in the third column. Outcomes are given, find out the probability, find out the expected value as given in the formula, utility multiplied the probability, sum them up and the value is 6.91. If the utility function is p to the power 0.25, the corresponding utility function comes out to be, value comes out to be 33.63. Now, we will basically mention three properties of utility. So, the first concept is more you get, more you want, which is the concept of non-satiation, which may not be true in the actual sense. So, if I basically try to give an example why it is not true in the actual sense, let us consider a very simple example which may not make much sense from the theoretical point of view of project management, but it will definitely give you some idea. Say for example, one person likes sweets, and early in the morning I give that person, he is very hungry, he or she is very hungry, I give him or her 3 sweets. The person is very happy, eats it up and is really satisfied. So, again I ask this person, would he or she like to have more sweets? Person says yes, I give him or her the 4th, the 5th, the 6th, and each time the person relishes and takes it. Now, consider after the 10th one, the person's actual appetite has become 0. That means, he or she is totally full, cannot take any more sweets, and it has become very sweety for that person, and the person's stomach is full. So, in that case, when I offer him or her the 11 sweets, the person would try to say definitely or no, even though the person likes sweets, which means the overall benefit the person had in trying to consume the sweets. Benefit can be taste buds were titillating, the person was very hungry and such examples. So, for the 11th one the person says no, which means the utility value net worth the person is gaining by consuming each one extra unit of sweets, like trying to invest, is now coming out to be negative, which we would not consider for the concept of non-satiation. So, it gives the definition that the first restriction placed on the utility function is that more is always preferred to less. This means that between two certain investment, we will always take the case where the utility function for W plus 1 would be positive and greater with respect to UW, which means the first derivative is 0. The second one is that we consider the investors or the decision makers perception of absolute risk to be based on 3 facts. One is concept of risk aversion, next is the concept of risk neutrality, and the third is the concept of risk seeking. So, let us consider that with a simple example. So, consider the person, I am trying to basically play a game with you, and there are 2 outcomes. There is the coin which is the actual Indian unbiased 5 rupees coin, and the probabilities are half and half, and consider you invest something and the outcomes are you get 2, outcome 2, that means the net value which you get 2 with probability half, and another you do not get anything and it is half. So, that means you invest some amount of money and the net outcome is 2 with probability half, and you invest some amount of money, the net value is 0 with probability half. In the other case, you consider the Sholay coins. I am sure all of the participants must have seen the famous Amitabh Bachchan film Sholay, where the coin basically had the heads on both sides. So, consider you toss that coin and the investment which you do gives you a value of 1 with probability 1. So, if you consider these 2 examples, it means that the expected value in both the cases are 1. 1 into 1 is 1, 2 into half plus 0 into half is 1. Now consider this is the fair gamble. Let us now slowly change the stake. In case of the coins, they remain the same, but let us consider that the overall value which you are getting is not 2, not 1 or not 0. 0 remains 0, but this value now becomes 20,000, this value becomes 10,000. So, in this cases expected value remains the same, because 20,000 into half plus 0 into half on one side and 10,000 into 1 on the other side. What is interesting to note is that as I keep increasing the stakes, at some point of time there I will find out a person in the initial case was definitely aiming for this, at some other stage, at some other value, person would be indifferent between these two decisions, and in the third case the person as I increase the stake, the person would definitely switch on to the deterministic sense, which means that the concept of risk aversion, risk liking, risk indifferent concept would be based on the fact what is the utility function, what is the amount of money which is being invested, and how the situation is being handled. With this, I will close the 14th lecture and continue with the discussion of utility analysis with more examples to come, and it is relevant to the project management. Have a nice day. Thank you.